What's up, everybody, and welcome back to OpenStax Algebra and Trigonometry, Chapter 2, Review Exercises. Let's do it. For the following exercises, find the x-intercept and the y-intercept without graphing. So if we remember, the x-intercept occurs when y equals 0, and the y-intercept occurs when x equals 0, because x-intercept, you're intersecting the x-axis, hence y is 0, and vice versa with the y-intercept. So if I just plug in 0 for y, that zeroes out. I get 4x equals 12, and x equals, divide both sides by 4, 3. So my x-intercept is at 3, 0. Likewise, when I find the y-intercept, I plug 0 in for x, and I get negative 3y equals 12, divide both sides by negative 3, y equals negative 4. So my x-intercept is 3, 0. My y-intercept is 0, negative 4. Done. For the following exercises, solve for x in terms of y, putting the equation in slope-intercept form. So what we're going to do is we're going to isolate y. So first, I'm going to add 12 to both sides. So I'm going to say 3y equals 5x plus 12. So we're just trying to isolate the y. I'm going to rewrite this because I like slope-intercept form to be having the y on the left side, but it's the same thing. And then last step, I'm going to divide everything by 3, like so. Boom. And that gives us y equals 5/3 x plus 12 divided by 3 is 4. Boom. Done. For the following exercises, find the distance between the 2 points. We're going to use the distance formula. So distance equals square root of the difference of the x values squared plus the difference of the y values squared. So what are the x values? Negative 2 and 4. So I'm going to just go left to right. Negative 2 minus 4. And then 5 and negative 1. So 5 minus negative 1. Double negative becomes a plus. Now we've got negative 2 minus 4. That's negative 6 squared. 5 plus 1 is positive 6 squared. And the square root of all this. 6 squared, negative 6 squared, is 36. Positive 6 squared is also 36, which gives us the square root of 72. Now, if we reduce this, we can recognize that 72 is the same as 2 times the square root of 30, or 2 times 36. And the square root of 36 is a perfect square, so I can pull a 6 out, right? Square root of 36 is 6. So my final simplified answer is 6 rad 2. Done. Find the distance between these 2 points using your calculator round to the nearest thousand. So first, let's just use the formula. Distance equals square root of, and then we're taking the difference of the x values and the difference of the y values. So this would be negative 71 minus 511. And over here it'd be 432 minus 218, right? So we'll do as much as we can mentally before we use a calculator. So now negative 71, minus 511 is negative 582 squared. And this one, 432 minus 218, that would be 214 squared. And I'm keeping the parentheses here because it's a negative. So using a calculator, we're going to take the square root of negative 582 squared. Notice I keep that parentheses right there because we're going to include everything, plus 214 squared, and then I'm going to end the parentheses, so that's going to capture everything. So we're going to hit enter, and we got 620.0967. We're rounding to the nearest thousandth, so that'd be this digit right here. So it's 620.097. So 620.097. Boom. Done. Here we're meant to find the coordinates of the midpoint of these 2 points. So the way you do that is you take the average of the 2 x coordinates and the average of the 2 y values, right? And that's going to give you your x and y. So negative 13 plus 17 is 4, and 5 plus 18 is 23 over 2. So we can simplify as 4 over 2 becomes 2. We'll leave that as 23 halves, same as 11.5. Boom, done. So for this question, we're going to make a table and then plot 3 points and make a graph. So first I'm going to say x is 0. When x is 0, y has to be negative 2, right? Because that zeroes out. Negative 2 times negative 3 is 6. Next, I'm going to choose an easy value for x to make y a nice whole number. I'm going to choose negative 3 for x. That would give us negative 12 minus 3y equals 6. If I add 12 to both sides, I get negative 3y equals 18. Divide by negative 3, y would be negative 6. Last but not least, I'm going to make x positive 3. Again, I'm just choosing arbitrary values just to give us nice whole numbers. So that'd be 3 times 4 is 12. 12 minus 6 gives us 6. That means that y would be 2, right? 3 times 4 is 12 minus 3 times 2, 6. 12 minus 6, 6. There we go. We got our 3 points. So we're going to graph now. We got 3, comma 2. We've got -3, comma -6. And then we've got 0, comma -2. Now, if we plot all these out like so, boom, we have the nice graph of the line, and we're done. Here we're simply solving for x, so I'm going to start by distributing. We got 3x plus 6 minus 10 equals x plus 4. Then we're going to combine like terms. 6 minus 10 is -4 equals x plus 4. Then I'm going to isolate, so I'm going to add 4 to both sides first to get the numbers together. And then we got 3x equals x plus 8. Then I'm going to subtract x from both sides like so. 3x minus x is 2x equals 8. Last but not least, we're going to divide by 2, boom, and we get x equals 4, boom, done. So first we're going to solve for x by distributing this -5. So I got 12 minus 5x minus 5 equals 2x minus 5. Now we're going to combine like terms. 12 minus 5 is 7. Then I'm going to add 5 to both sides like so, and I get -5x plus 12 equals 2x. Then I'm going to add 5x to both sides to get the x's and the numbers by themselves. So we got 7x equals 12. Last but not least, divide by 7. Divide by 7. Boom. We get x equals 12 over 7. Done. So here we are solving for x, and they're giving us the excluded values right here. X can't be -3 or +3 because that would zero out the denominator. We can't divide by 0. All right. So how do we solve something like this? We're going to start by factoring these denominators. That's a difference of squares. So that factors to x minus 3, x plus 3. And we got the same situation here on the right side. So that's x minus 3, x plus 3. Next, we want to get common denominators. I can get common denominators if I just multiply this one by x minus 3 on the top and bottom. Now, when all the denominators are the same, you can basically go like this and just cancel them out. And now we get a really nice equation. We got x plus, let's go ahead and distribute this, 4x minus 12 equals 3. Combine like terms, that's 5x. Simultaneously, let's add 12 to both sides just to save a little space. 5x equals 3 plus 12, which is 15. Last but not least, let's divide both sides by 5. Boom, boom, and we get x equals 3. But that is one of the excluded values, which means that is not a viable solution, which means there is no solution. Done. Here we're meant to find the equation of the line going through these 2 points in point slope. So first, we got to calculate slope. The way we do that is we take the difference of the y values over the difference of the x values. And notice I'm going in the same order. I'm going left to right, left to right. Has to be consistent. I could go right to left, but we just have to be consistent on the top and bottom. So we get 1 minus 2, which is -1. -2 minus 4 is -6. Negatives cancel out. So we got a slope of 1/6. Now, in point slope, I'm going to arbitrarily choose one of the points to create the equation. So I'm going to use the second set of points, and that's going to be my y and my x that I'm going to use. So I'm going to say y minus that y value, or y1, which is 2, equals slope of 1/6 times x minus that corresponding x value of 4. Now to put this into slope-intercept form, we'll go ahead and distribute. We get y minus 2 equals 1/6 x minus 4/6, right? 4 times 1/6 is 4/6. I'll reduce that to 2/3. Last but not least, let's add 2 to both sides. So I'm adding it to 2/3. Let's make 2 have a denominator of 3. That would be 6/3. That's the same as 2. So my final answer is y equals 1/6 x plus 6/3 plus 2/3 is 4/3, boom, done. Here we're trying to get a linear equation that goes through this point and has the same slope as this because it's parallel. So that means it has a slope of 2/3. So check it out. Using point slope, I got y minus y1, which is 4, equals a slope of 2/3 times x minus -3, which is the same as x plus 3. Let's distribute. I get y minus 4 equals 2/3 x, and then 2/3 times 3 is 2. And I'm just converting it to slope-intercept form here. That's all I'm doing. But this is technically correct right here. Now I'm going to add 4 to both sides, and I get 2/3 x. 4 plus 2 is 6. Boom, done. So here we're going to write an equation to solve the question. So it says the number of males in a classroom is 5 more than 3 times the number of females. So that's 5 more than 3 times the number of females. If the total number of students is 73, meaning M plus F equals 73, how many of each gender are in the class? Guess what? I got a system of equations. I can solve this however I want using elimination or substitution. Let's roll with elimination. So I'm going to subtract 3F from both sides in this one. So I got M minus 3F equals 5. Now, how I'm going to use elimination, I'm going to negate, multiply everything by -1, because then when I add these together, the m's cancel out. And 3f plus f is 4f equals 73 minus 5 is 68. Divide both sides by 4, and I get the number of females is 17. Now to figure out how many males there are, I can go back to this equation, which was m plus f equals 73. Since I know that females is now 17, I can say m plus 17 equals 73. Subtract 17 from both sides like so, and I get m equals 56. So there are 17 females, 56 males. Boom, done. A truck rental is $25 plus 30 cents per mile. Find out how many miles Ken traveled if his bill was $50.20. So the rental, we can say it's $25 plus 30 cents per mile, where X is the number of miles. That's what we're trying to solve for. And this all equals $50.20. Now we can solve. So I'm going to start by subtracting 25 from both sides, right? 50 minus 25 is 25, and we leave that decimal on there, so 25/20. Last but not least, we're going to divide both sides by 0.3. So check this out. 25.2 divided by 0.3 is like 252 divided by 3, so that we can do mentally a little bit more easily. 3 times 80 is 240, and we need another 4 to get that additional 12. So this becomes 84 miles. Boom, done. We're going to use the quadratic formula to solve for this quadratic equation, which is -b plus or minus the square root of b squared minus 4ac all over 2a. And we got a, b, and c. Let's go. So we got -3 plus or minus 3 squared, which is 9, minus 4 times a times c all over 2a. 2 times 2 is, 2 times 2 is 4. So we got -3 plus or minus 4 times 2 is 8 times 7 is 56. 9 minus 56 is -47. So now I can recognize that this is -1 times 47. So that's really plus or minus I root 47 over 4. And the last thing they did in the answers, they split this up, because this can be represented as two separate fractions, as -3 over 4 plus or minus I root 47 over 4. Boom, done. Here we're trying to find the horizontal component and the vertical component. And this is on a graph where we have the real and the imaginary. Okay, so since the real part is the -2, -2 is going to be the horizontal component, meaning how far you go left and right. And then the vertical component is going to be the coefficient in front of that I. So the vertical component is actually going to be a -1. So if I were to plot this on the real imaginary XY axis, it would be -2 right out here on the real, and then -1 on the imaginary, and the point would be right there. Here we're going to simplify, and the best way to treat I in this case is like a variable like X. So check it out. First, we're going to distribute that minus. We got 2 plus 3i. Distribute the negative, that becomes plus 5. And then negative times -8i is positive 8i. Then we're going to combine like terms like so. 2 plus 5 is 7. 3i plus 8i is 11i. Boom, done. Here we're going to start by simplifying. So the square root of -16, we should really recognize this as -1 times 16. Likewise with -9. The reason why this is helpful is because we can take the square root of these individually. So the square root of -1 is I. The square root of 16 is 4. So those both come out of the radical. Likewise, the square root of -1 is I. The square root of 9 is 3. So those also come out. So that's multiplying that 4 in front. So last but not least, we get 4i plus 3 times 4i, which is 12i. And then 4i plus 12i is 16i. Boom, done. Here we're going to FOIL this guy, so I'm going to write it out as two binomials. Then we're going to go 3 times 3 is 9. 3 times -5i is -15i. Again, we've got another minus 15i, and then we got negative 5i times negative 5i. That's positive 25i squared. But here's where it gets interesting. I is the square root of negative 1. So I squared is actually negative 1 times 25 is negative 25. So now let's combine like terms. Here we got negative 15i minus 15i. That's negative 30i. And then we got 9 minus 25, which is negative 16. This is the simplified answer. Done. So this one, we're going to start by recognizing that negative 2 is really 2 times negative 1. So we've got I rad 2 times, again, I can take the square root of negative 1 because it's negative 1 times 8. That's I rad 8 minus rad 5. Now I can distribute. Boom, boom. So I rad 2 times I rad 8 is I squared rad 16 minus, and then the 2 and the 5 multiply, and I got I rad 2 times 5 is 10. I squared is negative 1, and square root of 16 is 4. 4 times negative 1 is negative 4, minus I rad 10, which can't be simplified. Boom, done. In this situation, we just don't want to have an imaginary number in the denominator. So the way I can accomplish that is if I multiply the top and bottom by I, or I over I, right? Because anything over itself is 1, so we're not really changing the value here. So this guy's going to distribute, and I'm going to get 3i plus 7i squared on top over I squared. Remember, I squared is negative 1, negative 1. So then I've got 3i, and then negative 1 times 7 is negative 7 over negative 1. When you divide both of these by negative 1, it's just going to flip the signs. So that's going to give me a positive 7 and a negative 3i. Just change it to real, then imaginary. This is the final answer. Here we're going to solve by factoring, and the first thing I want to look for is there a GCF, and there is. I can divide everything by 3. So I got x squared plus 6x plus 15 divided by 3 is 5 equals 0. The question is, what multiplies to 5 and adds to 6? That is 5 and 1. So I got x plus 5 times x plus 1, giving me two solutions. What's going to zero this out? That's negative 5. And what's going to zero this out? That's negative 1. Those are the solutions. Done. Here we're going to factor an x out of both terms. So I have x times 7x minus 9 equals 0. Now this is good enough to get a solution because now I got to figure out what's going to make this part 0 out. That's simply 0. And what's going to make this binomial 0 out? Again, it's this part over this part negated. So it's negative 9 over 7 negated, which is just positive 9/7. So these are the solutions. Done. Here we're going to solve by taking the square root of both sides. So if I take the square root of both sides, that kills that exponent. So now it's got x minus 4 equals plus or minus 6, right? We got to take the square root of 36. It's both of those values. So now we got two equations to solve. X minus 4 equals 6. X minus 4 equals negative 6. So we're going to add 4 to both sides like so. We get x equals 10. Add 4 to both sides. And we got x equals negative 2. Here are the two solutions. Done. Here we're going to solve by completing the square. When we start this, the first thing is we want to have no coefficient in front of the x squared. So I'm going to divide everything by 4. So I'm going to start with x squared plus 1/2 x minus 1/4 equals 0. Then I'm going to move that constant to the other side. So I got x squared plus 1/2 x equals positive 1/4. Then I'm going to figure out what goes here. That's going to be half of this squared. So half of 1/2 is 1/4, and then that value squared, which is 1/16. So I'm going to add 1/16 to both sides, okay? This is pretty cool because now I've created a perfect square. This is x plus whatever value was here that we squared, 1/4 squared. If you FOIL this out, you'll see you'll get x squared plus 1/4 x plus 1/4 x, which gives you the 1/2 x plus 1/16. So that's what we wanted. Then we got 1/4 plus 1/16. Let's get common denominators. That becomes 4 over 16. So that becomes 5 over 16. Now we're going to take the square root of both sides. And I got x plus 1/4 equals the plus or minus square root of 5 over what is the square root of 16? Because I can break it up. That is 4. So once we subtract 1/4 from both sides, we have negative 1/4 plus or minus the square root of 5 over 4. Boom, done. Here we're going to solve using the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a, where this is a, b, which is negative 1, and c, which is negative 2. So we got negative 1, which is 1, plus or minus the square root of b squared, which is negative 1 squared, which is just 1, minus 4a and c all over 2 times 15, which is 30. Okay, so then we got 1 plus or minus. This becomes 4 times 15, which is 60, times 2 is 120, right? Because the negatives are going to cancel out. Plus 1 is 121 over 30. How nice. That's a perfect square. So that becomes 11, right? Square root of 121 is 11 over 30. So we got two solutions. We got 1 plus 11 over 30, which is 12 over 30. And then 1 minus 11 over 30, which is negative 10 over 30. Now dividing this one by 6 on top and bottom, we've got 2/5 as one solution. This one dividing by 10 on top and bottom, and negative 1/3. So these are the two solutions done. Here we can solve using any method. I'm going to choose completing the square. Why not? So I'm going to first start by subtracting 10x from both sides, like so. Then I'm going to take half of negative 10, which is negative 5, and I'm going to square it. And I'm going to add that to both sides, which is 25, like so. Boom, boom. Then I'm going to factor this left side, and I know it's a perfect square, and it's going to be x plus whatever this is, which is negative 5. And if you FOIL this out, you'll get this trinomial. Equals 3 plus 25 is 28. Then I'm going to take the square root of both sides, and I get x minus 5 equals plus or minus square root of 28. 28, by the way, is 4 times 7. So I can take the square root of 4, which is 2. So now I've got x minus 5 equals plus or minus 2 rad 7. Last but not least, I'm going to add 5 to both sides, and my solution is 5 plus or minus 2 rad 7. Boom, done. So what I'm going to do here is I'm going to actually use substitution. I'm going to set y equal to x to the 1/4, that term. That means that y squared is this squared, which is x to the 1/2. So that's pretty cool because now I can rewrite this as y squared minus 4y. Now I can factor out a y, and I can say y times y minus 4 equals 0. This means that my two solutions for y are 0 when this zeroes out, and 4 when this one zeroes out. Now I can plug it back into my original equation and solve for x. So when y equals 0, x to the 1/4 is 0. Well, that only is possible if x is 0. So we got one solution for x, which is 0. Then we've also got 4 equals x to the 1/4. So in this case, what is x? Well, to solve, we're going to take both sides to the 4th power, right? 4 times 1/4 is 1. And then 4 to the 4th power, 4 squared is 16, then 64, then 256. Those are the answers done. Here, I'm going to factor out 3x cubed. That's a GCF of both. That leaves an x squared in here. That leaves a minus 2 over here. Okay. So now we got 3 possible solutions, right? First, what's going to zero this piece out? That's going to just be 0. Then I got to figure out what this is. So when is x squared minus 2 going to zero out or equal 0? I'm going to add 2 to both sides, and we get x squared equals 2. Then I'm going to take the square root, and I get x equals plus or minus radical 2. So my solutions are 0, rad 2, negative rad 2, done. In this one, I'm going to start by subtracting square root of x plus 2 from both sides. Next, I'm going to square both sides, and that's going to require me to FOIL on the right side. But on the left, it just becomes 3x plus 7. On the right, I'm going to rewrite this. I'm going to FOIL it out, and you'll see what we do. So I got 1 times 1, which is 1. Then I got minus radical x plus 2. Then again, I got minus radical x plus 2. So that's going to give me minus 2 radical x plus 2. Then last but not least, those two multiplying each other is just going to liberate it from the radical. So it's going to be x plus 2, negatives cancel out. Now we're going to combine like terms. So we got 3x plus 7 equals 1 and 2 make 3 minus 2 rad x plus 2 plus x. Now we're going to isolate the radical. So I'm going to subtract 3 from both sides, boom, and I'm going to subtract x from both sides, boom. And I get 2x plus 4 equals negative 2 rad x plus 2. Let's go ahead and divide by negative 2 as well. Divide everything by negative 2. I get negative x minus 2 equals radical x plus 2. Last but not least, let's square both sides. Negative x minus 2 squared. If I wrote that out up here, let's see, negative x minus 2. So I got negative x times negative x is x squared. Negative x times negative 2 is 2x. Negative 2 times negative x is 2x again. That's 4x. And then I got negative 2 times negative 2 is 4 equals, and then the square root's just gone x plus 2. Okay, we're almost there. So we're going to subtract x from both sides. That's going to be 3x. Subtract 2 from both sides. That's going to be 2 equals 0. And I'm going to end by factoring here. So we've got x, what multiplies to 2 and adds to 3, that's plus 2 plus 1. So we got two solutions of negative 2 and negative 1. But now we have to see if there's any extraneous solution. So we got to plug them in and check it out. So if I plug in negative 1, I get negative 3 plus 7 is 4, square root of 4. Plug it in here, I get plus square root of 1. Does that equal 1? No, because we're taking the positive roots. That would be 2 plus 1 is 3, not 1. So negative 1 is extraneous. What about negative 2? Negative 2 times 3 is negative 6 plus 7 is 1. Negative 2 plus 2 is 0. Square root of 1 is indeed 1. So negative 2 is the solution. Boom, done. Here I'm going to start by adding 5 to both sides like so. And I got absolute value of 2x plus 3 equals 14. Then I'm going to split this into two equations. First, I'm just going to remove the absolute value and keep it the exact same. In the second one, I'm going to negate the right side, so make it negative. Now I'm just going to solve both of these. We're going to subtract 3, boom, boom. 2x equals 11. Then I'm going to divide it by 2, and x equals 11 over 2. So that's one solution. The other one, let's subtract 3 as well. And I get 2x equals negative 17, right? Negative 14 minus 3 is negative 17. Divide by 2, divide by 2. And x also equals negative 17 over 2 for the win. Done. So here we're going to isolate x and solve the inequalities. I'm going to start by subtracting x from both sides. That's negative 3x plus 5 is greater than negative 7. Then I'm going to subtract 5 from both sides like so, and that's negative 3x is greater than negative 7 minus 5 is negative 12. Last but not least, we're going to divide both sides by negative 3. We get x is less than 4, because when we divide by negative, we flip the inequality. X is less than 4. What is that in interval notation? It's everything starting from negative infinity up to, but not including 4, which means we have a parentheses up here. This is the answer. Done. So here we're going to start by isolating the absolute value. I'm going to start by subtracting 1 from both sides. So then I got absolute value of 3x plus 2 is less than or equal to 8. Then I'm going to split this into two inequalities and remove the absolute value. So I got 3x plus 2 is less than or equal to 8, just as is, with the absolute value stripped away. And then 3x plus 2 is greater than or equal to negative 8. So I'm flipping this and negating this. Now I'm going to solve these two inequalities. Subtract 2 from both sides. 3x is less than or equal to 6. Divide by 3. X is less than or equal to 2. Likewise, I'm going to subtract 2 here. 3x is greater than or equal to negative 10. Divide by 3. X is greater than or equal to negative 10 thirds. Since we started off here as less than, this is an and situation. That means it's the values between this and this. So in interval notation, we're starting down low, greater than and including negative 10 thirds all the way up to and including 2. Boom, done. Normally, we'd start by splitting this into two equations, but remember, when we see a negative on one side of an absolute value, it's going to either be no solution or all real numbers, right? Any solution of x will work. Well, this is saying this absolute value is supposed to be less than a negative, implying it will be negative as well. But absolute value is always positive or 0. That's the highest it can go is 0. So this is impossible, no solution, done. Here we're going to solve this compound equality. I'm going to kind of split it into two pieces. First, I got 1 minus 2y is less than 5 plus y, which is this on the left. Or sorry, right, excuse me. And then over here, 3y is less than 1 minus 2y. So it's just these two on the left. And now we're going to isolate. So I'm going to add 2y to both sides. 2y, that's going to give me 5y is less than 1. Divide by 5, y is less than 1/5. And then over here, I'm going to subtract y from both sides. 1 minus 3y, right? Negative 2y minus y is negative 3y is less than 5. So now I'm going to subtract 1 from both sides like so, and I get negative 3y is less than 4. Last but not least, we're going to divide by negative 3, and I get y is greater than negative 4/3, because when you divide by negative, you flip the inequality. Now, this is a compound inequality, which means it's an and situation. So it's everywhere starting as low as negative 4/3, going up to but less than 1/5, not including 1/5, and not including negative 4/3, because neither of these are greater than or equal to or less than or equal to. This is the winner. Done. So here we're meant to graph both sides of the equation as lines and then figure out when this side is less than this side. So we're going to start here. We've got a slope of 1, right? It says if y equals x plus 3 and a y-intercept of 3. So we'll go ahead and create this line here. And then we got this one. It's a y-intercept of negative 4 and a slope of 3. So here's negative 4. Slope of 3 is up 3 over 1, up 3 over 1, like so. And we're trying to figure out where this one is less than this one. So it looks like it will be less than it at this point going forward. So that's apparently where they intersect. It's not a nice intersection point, but it looks like that's where x equals 3.5 or 7/2. So we could say 7/2 or 3.5, and in interval notation, it's everywhere from 3.5 up to infinity, not including 3.5, because it didn't say less than or equal to, it says less than. It's less than from 3.5 on forward. I hope you guys enjoyed this video, and if you did, please click that like button. And if you want to see more from the Scalar Learning channel, make sure to click subscribe. Thank you guys so much for joining, and I'll see you in the next video. Take it easy.